Okay, so yes, we are live. Hello, everyone. I'm Sheldon from Phala Network, and today I'm very glad to invite Joshua Waller to our tech talk. This is going to be a hackathon workshop and we Joshua is an active developer of our community, and he have produced a very good application in our hackathon, and we invite him to introduce his work here. In today's tech talk, I will first give a brief introduction of our hackathon workshop, and then I will give the rest of time to Joshua for him to introduce his great work. Okay. First, our hackathon is still ongoing. It will be end in the October the 31st. So there is still 10 days for everyone to join. If you are interested in, please join and come to play. And in this hackathon, we have provided 3 challenges. The first challenges is the beginner challenges 1, and it's about following the tutorial to set up a local testnet and run our 2 demo DApps. And after you have doing that, you can post an issue to our submit an issue to our repository and win $25. And after that, we provide beginner challenge 2. And in this challenge, you will need to make a little improvements on either of our DApps, and after that, you will win another $25. And finally, we provide the advanced challenges. And anyone who wants to win the advanced challenge, you will have to build a full functional DApp based on our Phala confidential contract. And the first winner will win the $3,000. Okay, so if you are interested, just check our repository and try to join. Okay. Okay, I will, and then I will give a brief introduction of our contract highlights. And I think in the following example, Joshua will give a more detailed example about how he used these features to power his applications. And the first highlights I want to show is that we provide confidentiality in our contract in Phala Network. For example, in our first demo application, we show a guessNumber game. While such games cannot be implemented on the traditional smart contract form, such as Ethereum, because in Ethereum, all the states of the contract is public, and you can just access it from the blockchain data. All you need to do is you need to locate the sensitive variable and try to decode the data, and then you will know the real secret number. Okay, well, we can achieve this in our smart contract because our smart contract is executed off-chain in the Intel SGX, and all its memory is encrypted, all its state is encrypted, so no one can pick at the secret number. Okay, this is why the first demo applications can work. And the second important feature of our contract is that we provide some asynchronized tasks. We call it side tasks. And in our contract, you can deploy any side task as you like, and it can do many things. For example, you can deploy a side task to send a HTTP request to any existing HTTP service. And this can do a lot of things. For example, we give a demonstration of a BTCPriceBot. It's sent 2 kind of HTTP requests. The first is it send a request to the HTTP API to get the current BTC price, and then it send another HTTP request to the TG bot to report the BTC price to the Telegram, and then so you can receive the current price of the BTC on your Telegram bot. Okay, then I will leave the rest of time to Joshua to show his auctions examples. Joshua, are you ready?
Yeah, I'm ready.
Let's see. Now you can have your time.
Okay, can you see? I guess it's showing. Is it showing my screen now? Let's see. Should be good. All right, so I came up with a little video just last night and published it today. I'll put this in full screen. But essentially, so as Shevin was saying, I actually utilized the HTTP request from my smart contracts that from my Phala confidential smart contracts, and I'm going to display here. First, I'm going to go into building the Phala node, which I kind of skip over. Well, actually, I kind of cached my build, so you didn't have to wait for about up to 30 to 40 minutes for it to build. But in here, you'll see first, as you can see here, let's see. I'm going to like change into the Phala blockchain and build the node. And one of the things that was really helpful was before I did this development is I took the Substrate Runtime Developer Academy, and that really helped a lot, just getting introduced to a lot of just pretty much anything Substrate, because it's a lot of information. And then learning Rust is definitely a big learning curve too as well. So as I've kind of sort of started learning over the last, I would say, 7 months, it's been a lot of fun learning, and it helps to go through that. So I would advise anybody that is really interested to do that. Next in here, we go into the runtime, and we're going to run the SGX mode. So this is in the documentation for the hackathon, and you're going to run the switch make and build the runtime. As you can see, it's built here. And then I'm going to go back into the Phala blockchain node and deploy my Phala blockchain node. So here I'm going through the I'll press pause here, but this is the documentation here. So the documentation is really good. You can kind of follow through all the steps and figure out what configuration you need. So as you're going through there, depending on what operating system you're running. So on my example, I'm running Fedora 34. So, and my machine doesn't have an Intel chip, so I have an AMD. So I wasn't running it on the hardware. I was running the virtualized version. So that's why I had to run it with the SGX mode equals SW make. But I'll continue here. But as you can see, like, you can go through all the steps. You can run it yourself, and it's really intuitive and pretty easy to follow. And then also, if you go onto the Discord, they're very helpful, and then a lot of other people are also doing the same thing. So it's a lot of fun. You get a lot of support there.
Excuse me, Joshua.
Yes.
Are you share the right screen, because from our point your screen is frozen?
Oh yeah, I pressed pause. Sorry, I pressed pause to so it wouldn't go too fast.
Okay.
It should be playing now. I'm right here. I'm copying over the syntax to deploy the Phala node, and this is like a temporary dev node. And next, I'm gonna launch the runtime, the P runtime.
I think you are just sharing your Chrome. Are you need to share your terminal?
Is it showing a video or is it?
Now it's showing a crop tab on the YouTube.
Oh yes. Is it showing the video of my terminal? Because that's the just like the video showing exactly how to deploy, and then showing the it'll show the steps to deploying the smart contract.
And the video is not playing.
Oh, it's not playing at all. Ooh. Okay. Let's see. Because being able to run it on this machine, it'll be a little difficult. And you can, and based on what you're seeing there, it's just frozen on that one. Okay, that makes sense. I could just try to deploy on this. Let me try something real quick.
Don't worry, you still have a lot of time.
Oh, yeah. Yeah, I'm just seeing. It may take a little bit of time to deploy, but we'll see how it goes because it's not as powerful as the other machine I have.
Oh, I just saw a piece of terminal here.
Oh, is it delayed pretty bad?
Yes, some delay, I think.
Okay. Yeah, my connection might be pretty bad. I just actually moved into a new house, so let's see.
Yes, now we can see your Chrome.
Okay.
Ah, yes, we can see the wiki now.
Okay. Yeah, I think it has like a pretty big delay now. Let's see if I can pull up my GitHub real quick.
Oh, now we are on your main page.
Okay. Let's see here. Okay.
Oh, yes, we are good to go.
Okay, so come on.
Oh, yes.
Auction, NFT auction, okay. And you can see the terminal now, right?
Yes.
Okay, so I'm pulling in the changes now. Wonder if I have all of the changes here. Might not. I'll run the.
Maybe you can move your terminal to the middle of your screen, because now the command line is just at the bottom.
To the bottom. Okay.
Yes. You can move it to the middle, and we can have a clear view.
Okay. I can't. Because like it's on another screen on my machine, so I have like two screens pulled up, so it needs to be. So it's hard to.
Oh, okay, then just leave it there. Okay.
Right here. I wonder if I could actually get on with my other laptop, because the other laptop has it already cached in there and I could deploy it faster. Just had to connect into it.
Yes. Are you changing your device?
Not right now. Do you? I can try the other device too if since it would be faster, but I'd have to log into it back into the Crown Pass. Okay, so now it's all pulled in to the and I need to see if I can install.
Oh, it's installing the Rust toolchain.
Mm-hmm. Yeah, run the initialization script to make sure I have everything downloaded. Then I was going to then I'll pull up the documentation and start going through these steps.
Okay. So will you build the whole our project from scratch? Because I think it will take a long time.
Yeah, that's that's kind of what I was getting at. I wasn't sure if we should do that only because of how long it would take, especially with this one's not as powerful as the other machine I have. But I could potentially try to use the other one. Or I could do the video, but the I'm not sure if it's like good quality. Is it? Are you able to see the video very well?
Yes, I think we can just skip the building process.
Okay.
From my experience, if you are using a Mac virtual machine to build it, it may take about over half an hour.
Oh, so the remaining time. Okay. Let's see.
Okay, I can give us some brief explanation here, because Joshua is building a testnet version of our program. So to build a testnet, you don't need a real SGX hardware, and you can just have any hardware or virtual machines which can install your Linux distributions, for example, Ubuntu, Fedora, and others. And even you don't have the real SGX hardware, you can run the testnet. You can just install the Intel SGX SDK, and and you choose the SGX model to software simulation model, and then you can build the test and build your program for testing. Oh, okay, now your screen sharing.
Okay, can you see the video?
Yes.
Okay. I can continue from here since it'll just take through the steps. Hopefully it's not stuck like before May. Can everybody see it right now? Like where it's moving into? Well, it just stopped. Oh man. All right, there. So where it's at right now, it's about to build the front end for the Ghost auction. Right now I'm checking to see if these are set here for the environment, the local environment variables. And then this is launching it for the front end.
Yes, we have some suggestions in the comments zone, and maybe you can have a look.
Mm-hmm.
And I think it's a good idea to post all the video links here. And if your network status is not good, we can watch this ourselves.
Okay, yeah, I think, did Laurent, what's this thing? Oh yeah, he posted there. Okay, yeah, thank you. Bye-bye. All right, right now the timestamp is at 4:04.
Okay, 4:04. What about I sharing the screen for you, I think?
Oh, okay. That'd be perfect. I'll close mine.
So, is it okay?
Yeah, it looks, I can see it.
Okay, let's begin.
All right, yeah, so it's deploying the front end.
Oh.
For the
Oops. Okay. Now you have compiled your front end and
launched it, and then I'm gonna go to the local host on port 3000. So here it says the NFT. So right here it's like I was showing the remark HTTP endpoint that I'm going to query, and it's going to be It's a representation of one of the NFTs I've created on Singular. So I'm using the Remark 1.0 standard, but I worked with the Remark team to be able to get endpoint to be able to query and make an HTTP request with my NFT Ghost Auctioneer bot. So here I'm going to sign the certificate. Here, and some of the things that are like pre-populated are the NFT ID and the NFT reserve price and auto bid. It's going to auto bid by 1, but I did that so it could have an example for someone to come in there. Here's the little NFT I made. It's Hash Warlock, little block figure. And let's see. Oh yeah, and I cut out the bot token so no one uses the bot, but I added the chat ID, and that's going to be for the Telegram group, and that's the chat ID right there. And so after that, I will be here I'm just showing that it's the same thing as the Remark NFT ID that's populated in there right there. And then I'm submitting the new ghost auction. And so here I'm going to be able to send the HTTP request to the Remark endpoint. And I'm going to display the logs here and kind of show show me getting the data back from the endpoint and then parsing it. So here it says the command was sent, and you can see I'll end up highlighting it, but
okay, I see it.
Yeah, and there's that info right there. And then I parse it below it where it says Remark NFT ID, Remark NFT name, Remark NFT metadata. I put that in there just to show that we can iterate through the information and pull that into whichever data structures we put together, just to show that it's possible and that we're getting the correct information. And then lower down, you'll see that it'll take that information and then send a message to the Telegram chat.
Oh.
And there's the Telegram chat with the message that came from the smart contract, which I thought was really cool, but yeah. But yeah, it was like something really simple, but I thought to me, I thought it was really cool because.
我是小白，这是
Oh, sorry. Yeah, I thought it was really cool because I think a lot of people don't know this capability exists, and there's a lot of like creative things that you can do with it. Honestly, people with maybe a little more experience with TypeScript or Substrate development, and to me, I feel like it's very powerful, and that's why I kind of wanted to do a little ghost auction bot, because I've played around with different Remark NFTs and the communities, and a lot of them are kind of doing these ghost auctions by hand, and they may get overwhelmed as they get more users. So being able to automate that part for them, at least until some of the front ends get auction capabilities, would be pretty nice for them, and being able to have a channel where the owner of the NFTs can send messages to the channel saying that, hey, there's a drop coming soon, just sort of like how the video showed, and then being able to like expand on that and allow them to do some like bids, but not so much putting their collateral behind it, because that's how all these ghost auctions are right now. And I think it getting more input maybe from community and seeing like what are their pain points and being able to integrate that into the product would be a lot of fun, because I really wanted to do that for my project too as well. So that's what really kind of kickstarted me to get into the development and ask the question if we could use the HTTP request to communicate with Remarks API.
Okay, great. So in conclusion, you are using the HTTP request to do two things. The first is to send the auction bidding to the Remark network, and the second is to report the results to our Telegram bots. Is that right?
Yes. 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 Setting up the auction configuration, and then being able to make sure that NFT does exist first, and then report to the Telegram group that it's about to start and they should be ready to start bidding.
Great. Okay, let's see. So if the audience have any questions, you can just post it. And I saw Lawrence here.
Yeah.
Yes. Lauren has also done a very good job. He has developed a POS manager based on our contract, and U2's maybe good competitor, I think.
Yeah, his is his is great. Honestly, like he had like top to bottom. I was so impressed. I was like reading through the docs and watching this video. I mean, it is really good, and I mean the functionalities there too. I really like it a lot. I'm glad I got, like, it kind of helped me too, like with development. And just
Great.
This is really good.
And maybe your bidding bot you can also make it a Chrome extension, then so it can be more easy to use for most of the users.
I have to I have to ask Lauren about that.
Oh, great. Seems we don't have many questions here.
Oh, there's my friend, Joe Maggio. He's a chef out in California. He's a really good guy.
Hello. Yes, great. So if there are no more questions, I think first we will thank Joshua for his sharing here, and then after we have finished our hackathon, maybe then we will announce the prize winner, and I think maybe we are welcome anyone to use our applications from our winners and our hackathon participants. Yes. Any questions? Oh, yes. I think I saw a question here. What kind of interaction are between Remark? Is it possible to trade on it? Yes. Josh, can you answer this question?
I don't see it. Where is it at? Oh, what kind of interactions are between Remark? Is it possible to trade on it? So for right now, the current implementation and the endpoint that I'm interacting with is just purely just visibility and not being able to make any kind of state changes. So right now, it does not have that type of interaction, but I believe that I can talk to the team and see if that's a possibility. That'd be really cool to do. That's kind of like the idea. It's just baby steps. Users send queries to the smart contract. I understand.
Yes, there are two questions from Sai Geo, I think. And the first is when users send queries to the smart contract, I understand it was going directly to the TE. For when users send the commands, and since this goes to the blockchain first, yes, that's right. Does this mean other users will be able to see your commands? Okay. This question, I think I can answer these questions. So here's the story goes, and no matter the queries or the commands, all of them are encrypted. This is because for each contract we have assigned a contract key, and we use the contract key to establish an encrypted channel and with the ECDH. And after that, a working key is generated during the ECDH process, and then this key is used to encrypt all your queries and commands. So you don't need to worry about the privacy problems here. And if you have tried our demo application, and just as shown by Josh right now, and you can see the first things when you need to send the queries is that you need to sign a certificate. This is because your key is managed by the Polkadot.js extension, and if you have not signed the certificate, it will prompt you every time it's try to use the key. And after you have signed the certificate, you don't need to sign the transaction every time in the following about 15 minutes. And this is what we are doing when you sign a certificate.
Also, I added to the question for what kind of interaction are between remark. Is it possible to trade on it? I did add the remark tools. They have some tools there, and I took one of their training sessions, and I didn't get too deep into it, but it has some like good material there, and that was something I wanted to see if there was more, but I haven't really played with it enough.
Oh, great. From it provides a lot of helpful APIs. And from my points, I think our side task features can power a lot of usage. Actually, in general, we can think any usable HTTP service with an API, you can use it in your contract and do the things you like to do. And you don't need to worry about the privacy or maybe someone will change your data. It won't happen because after the first time the data is returned from the side task, it is witnessed by our blockchain. And in the following all the execution, it will not resend the same request, and it will just read the previous results from the blockchain, so it will not change.
So I do have a question too from that functionality standpoint. So I work in like kind of in cybersecurity in this within an appliance that in the networking module. So one thing that I was thinking about with these smart contracts, can you pretty much create a generic network controller that could be able to send command like a HTTP request to different devices to be able to configure them in certain ways based on the configuration?
In theory, we can do this, I think, because when you send the request or commands to your device, it's just like we send the request to our Telegram bot. So what's the difference between sending a request to a device and sending request to Telegram bot? I don't understand. Okay, there is one more question. Can you explain more how does the HTTP request works? Command trigger HTTP request. Is this request sending from every single node? Okay. So first of all, when you use the commands to send the HTTP request, it is not sent from multiple nodes. It's just sent from the workers which is hosted the smart contract, and this is because our framework is different from those, for example, Ethereum, because in Ethereum all the miners, they are executing the same smart contract in the same block, right? Right. In Phala Network, we detached the consensus with the computation, which means the smart contract is only executed by the one worker, the worker which you deploy the contract, and it will not be executed by the other workers. So no duplicate requests will be sent. And how will the nodes agree on the value returned from the HTTP request if changed over time? Okay. As I have just explained, for example, in the BTC price example, okay. First, I will say our side task is deterministic. When we say deterministic, it means when the time it sends the request is deterministic as the specific block height, right? And when it will report the results is deterministic. Because in our example, you will specify, for example, after I have sent the request, my response will be posted on chain after 5 blocks. So the time you will report the results is deterministic, and after you have reported the received price, it is witnessed on chain. So you will know, for example, at the height of blah blah blah, and the price of the BTC is for example for $40,000. So it is deterministic. Single work. Okay. There is no guarantee that the single work won't go offline, and to ensure the availability of your contracts, a good solution here is try to deploy it on the multiple workers. And since the determinism I have just explained, and the behavior of all the deployed workers shall be the same, and only the first response which has been posted on chain will be treated as the real results of your side-task execution. Okay, great. If you have more questions about side tasks, maybe I think we can discuss it on our Discord channel. And I think this should be all for our tech talk today. Oh, great. Thanks. Thanks, Josh, for coming to our tech talk today.
Yeah, thanks for inviting me. Thank you very much.
Yes, thank you. So, okay, that's all. Bye-bye.